Hey guys, this is the second video in the series, and on this one I'm going to be introducing transformations. Hey guys, and welcome back. Franck here, and if you haven't done it yet, go ahead and subscribe to my channel. Today I'm going to be giving you an introduction to transformations of functions, and the first thing you need to know is that a transformation is simply a modification of either the output y or the input x. And today we're going to look at three kinds of transformation. We're going to look at shifting, and then we're going to look at stretching and shrinking. Those two go together. And finally, we're going to look at reflecting over the x or y axis. And so when it comes to the first two kind of transformation, the shifting and the stretching slash shrinking, it's very important to know that whenever you're transforming the output y, whatever you see is being done to the y is what you do. And when the input x is being transformed, you do the opposite of what you see. And so in addition to shifting and stretching slash shrinking, you can also just negate the input or the output, which would cause the graph to flip over the x or the y axis. And so for instance, if you were to negate the output y, then your graph would completely flip over the x-axis because all the positive y will become negative and all the negative y will become positive. But if you were to negate the input, then you would completely flip the graph over the y-axis because all the positive x will become negative and all the negative x will become positive. Let me give you some examples so you can see this in action. And so the first thing I will show you here is what happens when you are shifting output y. And so my basic function here that I'm going to consider is going to be the function f of x equals to the square root of x. And then I'm going to have two other functions here. G of x equals to the square root of x plus 2, i.e. we're just adding 2 to the original function. And then the next one is going to be h equals to the square root of x minus 1, i.e. we're just subtracting 1 from the original function. And so to graph these, I'm going to draw my plane here very quickly. And then after I'm done with this, I'm going to first graph the basic function. And then I'm going to show you what happened when this basic function is being modified by a shift. And so for the basic function here, if you've listened to my previous video, you know that my basic points are going to be 0, 0, 1, 1, and 4, 2. And so with these 3 points, I can connect them together to get the graph of the function square root of x. And so next, I'm going to graph the function g of x equals to square root of x plus 2. And so here, remember, whatever is done to the output y is going to be reflected exactly on the graph. And so since we are adding 2 here, we're going to be shifting our graph up by 2 units. And so the point of coordinate 0, 0 is going to become the point of coordinate 0, 2 right here. And so the next point here also is going to be shifted up by 2. And the last one here also shifted up by 2. And so with these 3 points together, we can connect them again, and you're going to have the graph of this particular new function, g of x equals to the square root of x plus 2. Next, let's look at what happens when you subtract 1 to the function. And so our function h of x here is going to be the same as the function f of x, but all the y output are going to be shifted down by 1. And so you're going to have the point of coordinate 0, 0 here, finding himself at coordinate 0, negative 1. Also, the point 1, 1 is going to be now the point 1, 0, and the point 4, 2 is going to be now the point 4, 1, because all the output are being shifted down by 1. And so with that, you can connect all these points together, and you get a new graph, and you're done. Next, let's consider this new function, g of x equals to 3 times square root of x, and h of x equals to 1/2 times the square root of x. Here we're going to look at stretching and shrinking of the output. And so whatever you see is whatever you do. And so since our graph g of x here is equal to 3 times the original graph, all we have to do here is multiply our output y by 3. And so the point of coordinate 0, 0 is still going to be 0, 0 because the output y equals 0 times 3 still gives us 0. But the point of coordinate 1, 1 will become the point of coordinate 1, 3 because 3 times 1 is 3. Finally, the point of coordinate 4, 2 will become the point of coordinate 4, 6. And so with these 3 points together, you can connect them and you get the graph for the function g. For the function h, we're going to do the same thing. So you can either multiply all the output by 1/2, or you can look at h as the square root of x divided by 2, which means you can divide all the output by 2. Whatever you do here don't matter. It's the same thing. Multiplying by 1/2 and dividing by 2, the exact same thing. So now I'm going to have the point of coordinate 0, 0 still at 0, 0 because division of 0 is still 0. And the point of coordinate 1, 1 is going to be at 1, 1/2. And the point of coordinate 4, 2 is going to be at 4, 1. And so with that, I can connect them together and get the graph for h of x. With that being done, let me show you what happened when the modification are applied to the input instead of the output. So in this case, I'm going to have the function g of x as the square root of x minus 4. Notice that the minus 4 is inside the root, so it's affecting the x input. It is as if g of x here was equal to f of x minus 4. So the minus 4 is affecting the x input, not the y output. And we're also going to look at h of x equals to the square root of x plus 2. And so remember, for the graph of this function, since the input is being modified, then whatever you see, you're going to do the opposite. So for the graph of the function g of x here, since the input is being subtracted by 4, we are going to be shifting in the x direction towards the right side. So we're going to move 4 units to the right instead of 4 units to the left. So we're doing the opposite of what's been done to the function's input. And so for the points here, the point of coordinate 0, 0 is going to become the point of coordinate 4, 0. The point of coordinate 1, 1 is going to become the point of coordinate 5, 1. And the point of coordinate 4, 2 is going to become 8, 2. And so with that, you can connect them together and you get a new graph g of x. For h of x, since we're adding 2 to the input here, we're going to have to shift the graph of f of x 2 to the left to get the graph of h of x. So the point of coordinate 0, 0 is going to find himself at position -2, and the y value is going to be 0. Same for the point of coordinate 1, 1. We're going to have it now at coordinate -1, 1. And the point of coordinate 4, 2 is going to become 2, 2. And so with those three, you can connect them together and get a new graph corresponding to the function h of x. Okay, so let's see what happened when we are stretching / shrinking the x input. So for this particular case, I'm going to have g of x equals to the square root of x over 2. And I'm going to have h of x equals to the square root of 4x. Remember, we are doing the opposite of what we see here. And so since the input in the function g of x is being divided by 2, to obtain the graph for g of x, we are supposed to multiply the input x. And so looking at the graph of f here, we are going to multiply the input x of all of these points in order to obtain new points for the graph g of x. And therefore, the point of coordinate 0, 0 is going to stay at 0, 0. The point of coordinate 1, 1 is going to become the point of coordinate 2, 1. And the point of coordinate 4, 2 is going to become the point of coordinate 8, 2. With that, you can connect them together and you get a graph of g of x. On the other hand, for h of x, since the input x is being multiplied by 4, what we have to do is divide the input for f of x by 4. And so we're going to obtain new points. The first one at 0, 0. Next, the point of coordinate 1, 1 is going to become the point of coordinate 1/4, 1, because we're dividing 1 by 4. And the point of coordinate 4, 2 is going to become the point of coordinate 1, 2, because we're dividing 4 by 4. And so connecting these 3 points is going to give us the graph for the function h of x equals to the square root of 4x. Okay, so now we are done with the shifting, stretching / shrinking of the output and the input. So the last thing we need to talk about is what happened when we negate the output or negate the input. And so for this particular one, I'm going to have the graph g of x equals to negative the square root of x, which basically means negative f of x. So we are negating the output here. And then I'm going to have the graph h of x equals to the square root of negative x, which basically means f of negative x. So we are negating the input here. And so graphing these particular ones are very natural. Starting with the graph of f of x here, if you wanted to have the graph of g of x, you should know that all the output will be negated, which means that the point of coordinate 4, 2 is going to become 4, -2. And the point of coordinate 1, 1 will become the point of coordinate 1, -1. And finally, 0, 0 would stay at 0, 0. So we're just negating the y output here. And so the result of that will be that our graph f of x is being flipped over the x-axis to give us the graph of g of x. And finally, to obtain the graph of h of x, we are to negate the input of f of x. And so the point of coordinate 4, 2 will become negative 4, 2. The point of coordinate 1, 1 will become negative 1, 1. And the point of coordinate 0, 0, of course, would stay at 0, 0. And so with those 3 points, we can connect them together and observe here that negating the input is the same thing as reflecting the graph over the y-axis. And so with that, you've been introduced to the basics of transformations of functions. And so next time, I'm going to show you more interesting examples and guide you step by step on how to go from a basic function to a completely new function. Okay, so I know this video was a little bit long, but I think it was worth it. Give me a thumbs up if you liked it, and I will see you next time. Bye-bye.